Hello, Mr. Geslard here, and in today's video we're going to be talking about factoring. There's really three different types of factoring. The diamond problem factoring, which is one we're going to do first. Then there's the difference of squares, a common term factor, and then we're going to do a couple problems that combine one or more of those different factoring types. So the first thing I'm going to do is number one, and I'm going to factor this using our diamond problem method. If you know a different method of factoring, by all means, feel free to use whatever method you like, but when we're in class and when I'm going over them, this is the method I'm going to use. So the first thing I'm going to do is start off by just making our big X and filling it in. So when you make the X, what you want to do is take the very first term, or the X squared term, multiply it by the very last term, or the constant term. In this case, that gives me negative 14x squared. Then whatever that middle term goes on bottom. Now, what we want to do is we want to multiply two numbers to get to that number, and we want to add those same two numbers to get to that number. And we'll put those two numbers on each side here and here. So to figure out what goes there, what I'm going to do is I'm going to list all of the factors of negative 14. So with negative 14, you would have 1 and negative 14, meaning 1 times negative 14 is equal to negative 14. Or you have negative 1 times a positive 14. You could also do 2 times a negative 7, or you could do a negative 7, let me back that up here, or you could do a negative 2 and a positive 7. So each of those pairs of numbers will multiply to equal negative 14. Now what we need to do is say which ones of those will add up to a negative 5. So of those, which ones add up to a negative 5? And as it turns out, a positive 2 and a negative 7 add to negative 5. So that's where I put a 2x here and a negative 7x here. So these two numbers will multiply to equal negative 14 and add to equal negative 5. Now, I don't really have to list all of the factors. I just have to list them until I get to the ones that work. So I could have just stopped after 2, negative 7, realizing that that works in my diamond problem. So that's the first step. The second step now is to figure out what the factors are. So to do that, I'm going to go ahead and make a generic rectangle. So I'm going to go ahead and just make a rectangle and just put in some boxes there. And then what I'm going to do is fill in this rectangle and see what goes on the outside. Here's what I mean by that. Whatever this first term is, in this case it's just x squared, I put in this bottom left corner. You may have seen this done before, and some teachers put it in a different place, but I'm going to put it in that bottom left corner. Then I'm going to take this negative 14 and I'm going to put that in the top right corner. So those two numbers come from the original equation. The other two numbers come from what I discovered by multiplying to negative 14 and adding to negative 5. So I'm going to put a positive 2x here and a negative 7x here. Now, it doesn't matter which one goes where. You could put those in either place. I could have put the negative 7 up here and the positive 2 down here. It really won't matter when we're done with the problem. So now what I have to do is fill out the outside so that when I multiply the factors, it equals what's on the inside of the generic rectangle. So here's what I mean by that. If we start here, I have x and x. When I multiply x times x, that gives me x squared. Now, the other thing is I always want these two numbers here to be positive. I never want to put a negative in front there or a negative in front there. I want those to always be positive. Because if you did put a negative x and negative x, that still equals a positive x squared, but I want to keep those positive. So then all I do is I say, okay, what number times x will give me 2x? Well, x times 2 gives me 2x. So really what I'm doing is I'm saying that if I take this number here times this number here where they meet, and I multiply them together, that's going to give me 2x. Then I say x times what number gives me negative 7x? Well, that's just negative 7. So whatever you have on the outside becomes your factors. So this will be x plus 2 and x minus 7. And those are going to be my factors. So that's the first type, or just the diamond problem type. The next type we're going to take a look at is called a difference of squares. Now, to do a difference of squares, what we're doing is we first have to recognize what is a difference of squares. Well, a difference of squares is if you have two numbers that are both perfect squares. Now, 25x squared is a perfect square because 5 times 5 is equal to 25, and x times x is equal to x. And 36 is a perfect square because 6 times 6 is 36. Now, it must be a difference of squares, meaning you must be subtracting here. You can't be adding. Whenever you see a difference of squares, you can break it up into two parentheses with a plus and a minus. And all you do is you take the square root of the first term. Well, the square root of 25x squared is just 5x, and you put that first. The square root of the second term is just 6, so you put that second. And that's going to be your final answer. So it's just going to be 5x plus 6 times 5x minus 6. And this pattern works anytime you have a difference of squares. Okay, now the next type of problem I'm going to do, and this is a little bit different than the order that the questions are, is I'm going to go ahead and do a common term factoring problem. Now, a common term factoring problem, this is the third type of problem, is when you have some number that you can factor out of each term. Now, if I look at this, I have a negative 40 and a negative 12. So what I'm going to do is I want to say, what's the largest number that goes into both 40 and 12? Well, and that number is 4. Now, you can, at this point, factor out either a positive 4 or a negative 4. I'm going to factor out a negative 4 because I think it'll make the inside look a little nicer. But if you just factored out a positive 4, it would still be correct. Now, what I say by factoring out a negative 4, what that means is I'm going to divide each of these terms by a negative 4, and then I'm going to put them back in the parentheses. So, negative 40z divided by negative 4 gives me a positive 10z, and negative 12 divided by negative 4 gives me a positive 3. So, when it's factored, it will be negative 4 times 10z plus 3. Now, you can think of this as the opposite of the distributive property. We learned about the distributive property a long time ago, and that's where you take negative 4 times 10z and get negative 40z, negative 4 times a positive 3, and you get minus 12. So really what I'm doing is I'm kind of undistributing or factoring. So my answer for this one would be negative 4 times 10z plus 3. Okay. Now, let's go back and we're going to do another type of question here. And I'm going to do number 6. Now, this is a diamond problem also, but the difference between this and the first diamond problem example I did is notice that this has a leading coefficient of 2 and not 1. In other words, there's a number in front of the x squared. So I'm going to start off by doing my diamond problem again. So I have to take 2x squared times a positive 9, which will give me a positive 18x squared. On bottom, I'm just going to have a negative 9. So again, I need to know what two numbers will multiply to a positive 18 and add to a negative 9. Well, before I start off listing my factors, which I am going to do, I'm going to say, well, what kind of factors do I need? And here's what I mean by that. Since 18 is positive, I know I either have to have a positive times a positive equals a positive, or a negative times a negative equals a positive. So my two factors are either both positive or both negative. Now, when I look at what they add to, and I should have an x here, when I look at what they add to, they have to add to a negative 9. Well, if you add two positives together, it can't equal a negative number. But when you add two negatives together, it just becomes more negative. So that means I know that both my factors have to be negative. So that'll make it a little bit easier when I'm looking at what are my possible answers here. So I'm going to go ahead and do a negative 1 and a negative 18. That doesn't work. I'm going to do a negative 2 and a negative 9. That doesn't work because they don't add up to negative 9. Then I'm going to do a negative 3 and a negative 6. Well, negative 3 and negative 6 add up to negative 9, so I have a negative 3x and a negative 6x. So now I'm going to have to go back and do my box. So this becomes a little bit more complicated. When I look here, I have 2x squared here rather than just x, and I have 9 here. And then in these two spots, I'll have negative 3x, and I'll have negative 6x. Now, here's where it becomes a little bit more complicated. Because this is 2x squared, I have to have x and x to give me the x squared, but one of those has to be a 2x. Now, when I look at the 2x, remember, I have to take this number times this number to equal this one. So I can take 2 times some number, -3, to get -6. But if I put a 2 in here, there's no whole number that will multiply by 2 to give me a -3. So that's why I'm going to choose to put that 2 on the side and not on the bottom. So I have 2x there. So we have 2x times x gives me 2x squared. Now, 2x times -3 gives me -6x, and x times -3 gives me -3x. So my two factors are going to be x minus 3 and 2x minus 3. So there's just that little added thing about where do you put this 2. Okay, and then we just have one last question that I want to go over, and that question is going to have to do with combining a couple of these ideas. Specifically, I'm going to combine the common term factoring with the diamond problem. So if we look at this question for number 7, notice that I have a 3x squared here, 21x there, and a 30x. Whenever you get a problem that you need to factor, you should always start off by asking yourself, is there a common term factor? In other words, is there something I can factor out of each one of these terms? In this case, the answer is yes, and it's 3. Now, if I divide each of these things by 3, what I'll be left with in the parentheses is just x squared. Then we have plus 7x, and then we have plus 10. So now I'm going to do my diamond problem with that. So when I do that, I take 10 times 2x squared is going to give me 10x squared. Then I just have 7x on bottom. Now, if I list my factors out, remember, since the top is positive, I know that I have either a positive and a positive or a negative and a negative. Since the bottom is positive, then that means I cannot use the negative and negative, so I have to have 2 positives for my factors. So again, that'll just make it a little bit shorter list. So 1 times 10, that doesn't work, doesn't add up to 7. 2 times 5, that does add up to 7. So my answer is going to be 2x and 5x. So now when I do my box, I'm not going to go back to my original one here. I'm going to go back to what we had here after I factored the 3 out. So that's x squared and 10. Then we have 2x and 5x. So I have x times x. That's going to be 2. That's going to be 5. So my final factor is going to be 3. I can't forget about that 3 I factored out in the beginning. Then we have x plus 5, and we have x plus 2. So that's how you combine them. Okay, again, this is Mr. Geisler, and I hope that was helpful.